Welcome back to class, men. Today's discussion is going to be on trigonometry. So we're going to break trigonometry up into three parts. And today we're just going to learn the basics. And the word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. So we get the word trigonometry. And trigonometry involves triangle measurement. Today we're going to learn how to write a trigonometric ratio, and it's a ratio of the lengths of two sides of a right triangle. But those two sides are going to be based off of a acute angle. So what you'll see is we've already studied angle-angle similarity back in chapter 7. So a right triangle within a given acute angle measure is similar to every other right triangle with the same acute angle measure. So trigonometric ratios are constant for a given angle measure. So if you take a look, I've got triangle A, B, C. I have angle A being 35 degrees. If I was to look over here, I have angle J, which is 35. Then I have angle F, which is 35. So we know that all of these are right triangles based off of the right angle. So triangle ABC is similar to triangle FGH, which is also similar to triangle JKL. And we know that because of angle-angle. And if that's the case, then I could start comparing segment lengths. So if I was to look at segment AC over AB in this triangle ABC, then that's going to be proportional to FH over FG, which is also proportional to JL over JK. That's just an example of a trigonometric ratio, or just of a ratio, pardon me. So we're going to study some of the three most common types of trigonometric ratios, and those are the words sine, cosine, and tangent. So when we look at these, in triangle ABC right here, ABC, if it's a right triangle with acute angle A, then the sine of angle A, so we would say sine of angle A, it is abbreviated SIN, so it's not a sin, it's sine, so I have the sine of angle A. What is the sine of angle A? Well, if I look, it is going to be equal to the opposite side of angle A. So we've already studied this. I come over here, I travel opposite, I hit segment BC, that is the opposite side over the hypotenuse. And that would be AB. AB is my hypotenuse. So the sine ratio is the opposite of angle A divided by the hypotenuse. In triangle ABC, with acute angle A, the cosine of angle A, and we abbreviate the cosine with COS. So the cosine of angle A, it is equal to the adjacent side. So it is the side that is next to angle A, so that is segment AC, over the hypotenuse, which is AB. And lastly, I get this tangent ratio, and we call that TAN. So it is tangent of angle A. So if I look at angle A, the tangent of angle A is the opposite side, so BC, over the adjacent. Tangent is opposite over adjacent. So the adjacent side to angle A is AC. So there is a trick for memorizing trigonometric ratios, and it's known as SOHCAHTOA. It's a mnemonic device to help you remember the ratios for sine, cosine, and tangent. So if you use the first letter of each word in the ratios, that's how you get so, ka, toa. So if we look right here, the sine of angle A, so S sine, is equal to the opposite side, O, over the hypotenuse, H. So sine is opposite over hypotenuse. Cosine, C for cosine. What is that ratio? It is the adjacent side, A, over the hypotenuse, H. So cosine, ca, cosine adjacent hypotenuse. And lastly, we have tangent of angle A. It is the opposite over the adjacent. So T, tangent, O, opposite, A, adjacent. Okay, so what we're going to do now is we're going to practice writing these ratios. And it's not that bad. I really admit that. But there are some tricks. So looking at example number 1, it says, what are the sine, cosine, and tangent ratios for angle T? If I was going to do this problem on my own, first thing I'm going to do, or that I would do, is I would look, I'm asked to write the ratio for angle T. So we were always told that the right angle box points towards the hypotenuse. So I would just, right now, since this is my first go around, I would practice writing that this is the hypotenuse. We know that every single time that's the hypotenuse. So what would be the side that is opposite of angle T? So here's angle T. If I was to go directly across, I run into segment GR. So this is the side that is opposite angle T. And that leaves me with one side, and that is RT, and that is the adjacent side to angle T. So now all I have to do is write the ratio. The sine of angle T. Sine is the opposite side, which is 8, over the hypotenuse, which is 17. So I have 8/17 as the sine of angle T. What is the cosine for angle T? Well, again, if I was to look for the cosine says that it has to be the adjacent side. So this is the adjacent side over the hypotenuse. So the adjacent side in this problem, it is 15, and the hypotenuse we know is 17. And lastly, what is the tangent ratio for angle T? It is the opposite side over the adjacent side. So the opposite side of angle T is 8, and the adjacent side is 15. I've just finished example number 1. We have wrote the sine, cosine, and tangent ratios for angle T. And lastly, we have example number 4. It says, what are the sine, cosine, and tangent ratios for angle N? So I need to write that as a fraction and as a decimal. So again, I think it would be beneficial if we looked at angle N. I'm going to label this as the opposite side. This NM is the adjacent, and NL is the hypotenuse. So the sine of angle N is the opposite side, 35 over 37. We already saw from above that the opposite over adjacent for 35 37ths is 0.95. The cosine of angle N, so if I look at angle N, I'm going to get 12 37ths. And we've already saw that from above, 12 37ths is 0.32. And then the tangent of angle N, that is the opposite side over the adjacent side. So 35 is the opposite side, 12 is the adjacent, 35 twelfths to the nearest hundredth is 2.92. That's the end of today's lesson. I hope you guys understand the trigonometric ratios for sine, cosine, and tangent. Please check Schoology for your homework assignment, and we'll carry on with part 2 tomorrow.